Today we are going to do derivative of inverse trigonometric functions like sin inverse of f of x, cos inverse of f of x, tan inverse of f of x, cot inverse of f of x, sec inverse of f of x, and cosec inverse of f of x. These are all inverse trigonometry functions. And what is f of x? F of x is any given function. And today I am going to tell you how to do derivatives of inverse trigonometry functions. Derivative of all these functions. How will you able to do and how to do and what are the steps and what are the difficulties and where to be taken precaution. All these things I am going to tell in this video. Now first consider two functions, that is sin inverse x, sin inverse of f of x, and the second one y equals to cos inverse of f of x. Here the condition is that mod of f of x must be less than 1. Here also mod of f of x, that is the modulus of f of x, must be less than 1. Now dy by dx equals to 1 upon, here also for cos inverse also 1 upon. So in both cases, here is under root, here is also under root. But for sin inverse x there is a plus, and for cos inverse x there is a minus. That is the difference. Then 1 minus f of x whole square here, and here is 1 minus f of x whole square multiplied by f dash x. That is a derivative of f of x. What is f dash x? F dash x nothing but dy by dx. And even for cos inverse x, here is a multiplied by f dash x. Let us read now. If y equals to sin inverse of f of x, then dy by dx equals to plus 1 upon under root of 1 minus f of x whole square multiplied by f dash x. And for cos inverse x, that is y equals to cos inverse of f of x, then dy by dx equals to minus 1 upon under root of 1 minus f of x whole square multiplied by f dash x. Now let us do some problems on these two functions. One is the sin inverse f of x, cos inverse f of x. After that we shall be taking tan inverse and cot inverse. First let us understand how to do the derivative of sin inverse and cos inverse functions. Example number 1, y equals to sin inverse of 2 root x, find dy by dx. Solution, write as it is, y equals to sin inverse of 2 root x, let f of x equals to 2 root x. Therefore y equals to sin inverse f of x, dy by dx equals to differentiation of sin inverse of f of x. Here is a double bracket, it is with respect to x equals to 1 upon under root of 1 minus f of x whole square into derivative of f of x with respect to x equals to 1 upon under root of 1 minus 2 root x whole square into derivative of 2 root x with respect to x. Dy by dx equals to 1 upon under root of 1 minus 4x into, now 2 is taken outside, derivative of root x with respect to x equals to 1 upon under root of 1 minus 4x into 2, derivative of root x is 1 upon 2 root x derivative of root x is 1 upon 2 root x. Remember it. Now 2 get cancelled. dy by dx equals to, now dy by dx equals to 1 upon root x into 1 minus 4x. Both are in under root. 1 upon root x into under root of 1 minus 4x. Therefore, differentiation of sine inverse of 2 root x with respect to x equals to 1 upon root x into under root of 1 minus 4x. This is required solution. Now, example number 2. Example 2, y equals to cos inverse of 5x plus 6. Find dy by dx. Solution. First of all, we write as it is cos inverse of 5x plus 6. Now let 5x plus 6 equals to f of x. Therefore, y equals to cos inverse of f of x. We know that y equals to cos inverse of f of x. Then dy by dx equals to what? Dy by dx equals to minus 1 upon under root of 1 minus f of x whole square into derivative of f of x with respect to x. This is the formula. So this formula we will be applying here. Therefore, dy by dx equals to minus 1 upon under root of 1 minus 5x plus 6 whole square into derivative of 5x plus 6 with respect to x. This is as per as the formula. So minus 1 upon under root of 1 minus 5x plus 6 whole square. Derivative of 5x is 5 and derivative of 6 is 0. Therefore, dy by dx equals to minus 5 upon under root of 1 minus 5x plus 6 whole square. We don't expand this one. If required, we will doing, but in regular calculation, we don't expand 5x plus 6 whole square because here is a square. Some other time, if the q or 4 is coming, we don't expand it. So, what is the ultimate answer? Differentiation of cos inverse of 5x plus 6 with respect to x equals to minus 5 upon under root of 1 minus 5x plus 6 whole square. This is required answer. Example number 3, y equals to sine inverse of log x. Find dy by dx. Solution. First of all, we write the question as it is, sine inverse of log x. After that, let log x equals to f of x. Therefore, y equals to sine inverse of f of x. We know that derivative of sine inverse of f of x with respect to x equals to 1 upon under root of 1 minus f of x whole square into derivative of f of x with respect to x. So by using that formula, dy by dx equals to 1 upon under root of 1 minus log x whole square into differentiation of log x with respect to x equals to 1 upon under root of 1 minus log x whole square. We know that derivative of log x with respect to x equals to 1 upon x. Therefore, into 1 upon x. Therefore, final answer dy by dx equals to 1 upon x into under root of 1 minus log x whole square. And how to write that answer? We can write the answer like this. Therefore, differentiation of sine inverse of log x with respect to x equals to 1 upon x into under root of 1 minus log x whole square. This is required answer. Next example, y equals to sine inverse of 2 raised to x, find dy by dx. Solution, y equals to sine inverse of 2 raised to x, and let f of x equals to 2 raised to x. Therefore, y equals to sine inverse of f of x dy by dx equals to 1 upon under root of 1 minus f of x whole square into derivative of f of x with respect to x equals to 1 upon under root of 1 minus 2 raised to x whole square into derivative of 2 raised to x with respect to x. We know that derivative of 2 raised to x with respect to x equals to 2 raised to x log 2. Therefore dy by dx equals to 1 upon under root of 1 minus 2 raised to x whole square into 2 raised to x log 2. Therefore, differentiation of sine inverse of 2 raised to x with respect to x equals to 2 raised to x log 2 upon under root of 1 minus 2 raised to x whole square. This is required answer. Example 5, y equals to sine inverse of cos 3x, find dy by dx. Solution, here I am going to use the formula cos theta equals to sine 90 minus theta. This formula I am going to use, and the second formula I am going to use here, sine inverse of sine theta is equals to theta. So these are the two formulae I am going to use to solve this question. First of all, we are having y equals to sine inverse of cos 3x. Now cos 3x can be written as sine of 90 minus 3x as far as this formula. This is equals to 90 minus 3x. In place of 90, we can write even pi by 2. So here I have written the 90. In place of 90, you can write pi by 2 as well as. So we are having 90 degree minus 3x. So that is equals to pi by 2 minus 3x also can be written. Now after that, we have already solved the trigonometry part. Now we have to do the derivative. We simplified the trigonometry part. Now we are going to do derivative. What we are having? We are having y equals to pi by 2 minus 3x. Now differentiating both side with respect to x. Therefore dy by dx equals to derivative of pi by 2 minus 3x with respect to x. Pi by 2 is a constant, derivative is 0, and derivative of minus 3x is minus 3. Therefore, derivative of differentiation of tan inverse of cos 3x with respect to x equals to minus 3. This is required answer. Now, we are going to do derivative of tan inverse x and derivative of cot inverse x. Y equals to, suppose y equals to tan inverse of f of x, or given y equals to cot inverse of f of x. Then dy by dx equals to 1 upon 1 plus f of x whole square into differentiation of f of x with respect to x. Here derivative of cot inverse x, that is the minus 1 will come here, remaining part is as it is 1 plus f of x whole square into derivative of f of x. So now we are going to do problems on based upon the tan inverse of f of x and cot inverse of f of x. Next example, if y equals to tan inverse of 3x square plus 2, find dy by dx. Solution, first of all we write y equals to tan inverse of 3x square plus 2. Let f of x equals to 3x square plus 2. If that is a y equals to tan inverse of f of x, then dy by dx equals to 1 upon 1 plus f of x whole square into derivative of f of x. So this is equals to 1 upon 1 plus, what is f of x? That is a 3x square plus 2 whole square into derivative of 3x square plus 2. So implies dy by dx equals to 1 upon 1 plus 3x square plus 2, 3x square plus 2 whole square, and we don't expand this one, 3x square plus 2, and the derivative of 3x square is 6x and derivative of 2 is 0. So this is equals to 6x upon 1 plus 3x square plus 2 whole square. This is the dy by dx answer. So next example, example number 7. If y equals to cot inverse of 5x square plus 10x plus 5, find dy by dx. Solution, y equals to cot inverse 5x square plus 10x plus 5. Let f of x equals to 5x square plus 10x plus 5. Therefore y equals to cot inverse of f of x. Then if y equals to cot inverse of f of x, then dy by dx equals to minus 1 upon 1 plus f of x whole square into derivative of f of x with respect to x. Therefore 1 minus, what is f of x? That is 5x square plus 10x plus 5 whole square into derivative of 5x square plus 10x plus 5 with respect to x. This is equals to minus 1 upon 1 plus 5x square plus 10x plus 5 whole square into 10x plus 10. That is equals to minus 10 common, minus 10 x plus 1 upon 1 plus 5x square plus 10x plus 5 whole square. This is nothing but the result of dy by dx, and this is required answer. Example number 8, y equals to tan inverse of cos 2x upon 1 plus sin 2x. First of all, we will simplify the trigonometry part present in the bracket. First of all, we will simplifying cos 2x upon 1 plus sin 2x. Cos 2x can be written as cos square x minus sin square x, and 1 can be written as sin square x plus cos square x, and sin 2x can be written as 2 sin x into cos x. This is equivalent to cos x minus sin x, cos x plus sin x. A square minus b square, a plus b into a minus b, and here denominator can be written as cos x plus sin x whole square. This is equivalent to cos x minus sin x. Here is the cos x plus sin x divided by cos x plus sin x. That can be written twice, cos x plus sin x. This and this cut down. So what do you get here? What do you get here? You get here cos x minus sin x upon cos x plus sin x. Now what do you do? You take the cos x common. So we get here 1 minus sin x upon cos x, and in denominator cos x common, 1 plus sin x upon cos x. Cos x get cancelled, equals to 1 minus tan x upon 1 plus tan x. This is equivalent to tan of pi by 4 minus x. Therefore, y equals to tan inverse of tan of pi by 4 minus x. Y equals to, now here the formula, tan inverse of tan theta equals to theta. Therefore, tan inverse of tan pi by 4 minus x equals to pi by 4 minus x. Now, differentiating with respect to x. Therefore, dy by dx equals to derivative of pi by 4 minus x with respect to x. Derivative of pi by 4 0. Derivative of minus x is minus 1. Therefore, differentiation of tan inverse of cos 2x upon 1 plus sin 2x with respect to x equals to minus 1. This is required solution. Here, example number 9. If y equals to tan inverse of cos x plus sin x upon cos x minus sin x, find dy by dx. It is similar to the previous problem. We have y equals to tan inverse of cos x plus sin x upon cos x minus sin x. Taking cos x common, in numerator we get 1 plus sin x upon cos x. In denominator also cos x common, 1 minus sin x upon cos x. Cos x get cancelled. We get tan inverse 1 plus sin x upon cos x, nothing but tan x upon 1 minus tan x. Now what is the formula? Formula is 1 plus tan theta upon 1 minus tan theta equals to tan pi by 4 plus theta. This is the formula. Therefore, y equals to tan inverse of tan of pi by 4 plus x equals to pi by 4 plus x. Y equals differentiating with respect to x. If you are not strong enough at trigonometry, then go to my playlist. You will find lot of videos on trigonometry. So use those videos and learn something from those videos. Here differentiating with respect to x. So dy by dx equals to derivative of pi by 4 plus x with respect to x. Derivative of pi by 4 is 0. Derivative of x is 1. Therefore, dy by dx equals to 1. This is the required answer. Here, I want to revise one trigonometry formula, that is cot inverse 1 upon a equals to how much of the tan inverse a. So, cot inverse of 1 upon a equals to tan inverse of a. This is the relationship between the cot inverse and the tan inverse. Next question of derivative is depending upon this relationship. So let's do the next question. Next example, if y equals to cot inverse of 1 upon root x, find dy by dx. Solution. Here I want to revise the formula. Cot inverse of 1 upon a equals to tan inverse of a. Therefore, y equals to cot inverse of 1 upon root x is equals to tan inverse of root x. Therefore, y equals to tan inverse of root x, differentiating with respect to x. So, dy by dx equals to differentiation of tan inverse of root x with respect to x equals to here I would like to revise the formula. Y equals to tan inverse of f of x, then dy by dx is equals to 1 upon 1 plus f of x whole square into f dash x. This is the formula. Therefore, here is the root x nothing but f of x. Root x nothing but f of x. So, what is the derivative of this one? The derivative of this one is derivative of this nothing but 1 upon 1 plus f of x whole square, that is root x whole square into derivative of root x with respect to x. So that is equals to 1 upon 1 plus x, and derivative of root x is nothing but 1 upon 2 root x. So therefore dy by dx equals to 1 upon 2 root x into 1 upon 1 plus x. This is required solution. Next example, y equals to cosec of 4 tan inverse x, find dy by dx. Solution. We have y equals to cosec of 4 tan inverse x. Let 4 tan inverse x equals to f of x. Therefore, y equals to cosec of f of x, differentiating with respect to x. Dy by dx equals to minus cosec of f of x into cot of f of x into differentiation of f of x. Dy by dx equals to minus cosec. What is f of x? 4 tan inverse x into cot of 4 tan inverse x into differentiation of 4 tan inverse x equals to minus cosec of 4 tan inverse x into cot of 4 tan inverse x into 4 into 1 upon 1 plus x square equals to 4 minus 4 cosec 4 tan inverse x into cot of 4 tan inverse x upon 1 plus x square. This is required answer. Next example, y equals to cos inverse of under root of 1 plus cos 2x upon 2, find dy by dx. Solution. Before proceeding, we must simplify the part which is there in the root to 1 plus cos 2x upon 2. First we will simplify this in the rough work. Under root of 1 plus cos 2x upon 2, that is equals to 1 plus cos 2x is nothing but 2 cos square x minus 1 upon 2 equals to minus 1 plus 1 get cancelled, 2 cos square x upon 2 to get cancelled equals to under root of cos square x equals to cos x. So this is equals to cos x. Therefore y equals to cos inverse of cos x, that is equals to x. So y equals to x. Differentiating with respect to x. Therefore dy by dx equals to differentiation of x with respect to x, that is equals to 1. This is required solution. Example 13. If y equals to sine inverse of cos x plus sin x upon root 2, find dy by dx. Solution. In such problem, we have to see what trick we can apply. If you directly apply the basic formula, it will become very lengthy and sometime you will not get the desired answer. So such type of problem, first of all see, can you apply some technique or some trick? Like here I am going to apply some trick, that is nothing but I am going to simplify trigonometry part. Like the number is given in the denominator and check out is it a suitable number. Like here is the root 2, so separating into this one, so cos x plus sin x upon root 2 can be written as 1 upon root 2 cos x plus 1 upon root 2 sin x. Now 1 upon root 2 nothing but sin 45 and 1 upon root 2 nothing but cos 45. Now we have to decide what to write in place of 1 upon root 2. In place of 1 upon root 2, either we can write sin 45 or the cos 45. But what exactly to be written? Out of the two, which has to be written here? So here is the outside is a sine inverse. So inside the bracket, we see that the which formula will be suitable, like sine of a plus b equals to sine a cos b plus cos a sin b. This is the basic formula of trigonometry. So we see that can we fit these values in terms of sin a cos b plus cos a sin b. That means the 1 upon root 2 is there. In place of 1 upon root 2, out of the sin 45 and cos 45, we can write sin 45, so that it will be fitting into this formula. What is this formula? Sin a cos b cos a sin b. first sin A should come. So sin A, and already there is a cos x. Already there is a cos x is there. And after that 1 upon root 2 is there. 1 upon root 2 can be written as sin A cos B cos A, that is a cos 45 sin x. And this becomes sin of A plus B. So A equals to 45 and B equals to x. So sin 45 plus x. The 45 can be written as pi by 4 because it is a degree. The 45 degree it is. It is not a plain number. It is a degree. Therefore, 45 degrees can be written as a pi by 4 plus x. So this way, whenever such problems are given, you have to first think that can you make them in simpler form by applying some suitable trigonometry formula. After that, you start doing the dy by dx. Directly don't apply the formula, because which formula? That is a differentiation of sine inverse x with respect to x equals to 1 upon under root of 1 minus x squared. Directly don't apply this formula. First see, can you do the simplification? After the doing the simplification, it becomes simpler, then you can do dy by dx. So once again, y equals to sine inverse, and this becomes sine 45 dot cos x plus cos 45 sin x, which is equals to sine inverse of sine of pi by 4 plus x. Now formula, sine inverse of sine theta equals to theta. Therefore y equals to pi by 4 plus x. Now such a complicated form has been converted into very simple form. We got now totally the trigonometry here eliminated, and we got y equals to pi by 4 plus x. That we got a very beautiful algebraic form. And after getting this one, we do the derivative, that is a differentiating with respect to x. So dy by dx equals to differentiation of pi by 4 plus x with respect to x. So derivative of pi by 4 0 and derivative of x equals to 1. Therefore differentiation of sine inverse of cos x plus sin x upon root 2 with respect to x equals to 1. This is a required solution. Example number 14, y equals to sine inverse of a sin x plus b cos x upon under root of a square plus b square. Find dy by dx. How to do this solution? First of all, we split into the parts, that is separating a upon under root of a square plus b square into sin x plus b upon under root of a square plus b square cos x. Now we are having the two numbers here. One is a, b, and so what we do, we first of all make a triangle, and here is we try to suit this one into the formula because outside is sine inverse. So inside the bracket we try to convert into a plus b form, that is sin a cos b and plus cos a sin b. We try to convert the entire given problem in terms of sin of a plus b. So when you compare, the sin a is nothing but sin x, and cos b nothing but a upon under root of a square plus b square. Cos b nothing but adjacent side upon hypotenuse. So a is the adjacent side. Suppose you get here some theta, then a has to be adjacent side. So it is a adjacent side, and it is hypotenuse, that is a square plus b square. Now the b, here is a b upon under root of b square plus a square, that can be equivalent to sin b. That means, and sin b nothing but opposite side upon hypotenuse. That means b equals to opposite side. Therefore, this is, here we can write cos theta and here we can write sin theta. Therefore, y equals to sin inverse of cos theta into sin x plus sin theta into cos x. Writing properly, y equals to sin inverse sin A cos B plus cos A and sin B. Once again, sin A cos B plus cos A sin B equals to sin of A plus B, implies y equals to sin inverse. What is sin of? What is A? A is nothing but x. And what is the B? B nothing but theta. Therefore, y equals to x plus theta. What is theta? Theta nothing but tan inverse of b upon a. So, y equals to x plus tan inverse of b upon a. Now, differentiating with respect to x. dy by dx equals to differentiation of x plus tan inverse of b upon a with respect to x. Differentiation of x is 1 and differentiation of tan inverse of b upon a equals to 0. Therefore, dy by dx equals to 1. So, this type of problems are solved like this. Let us have one more example of the same type. Example number 15. Y equals to sin inverse of c into sin x minus d into cos x upon under root of c square plus d square. Find dy by dx. Solution. Y equals to sin inverse. First of all, separating, that is c upon under root of c square plus d square into sin x minus d upon under root of c square plus d square into cos x. And here is a sin x, so it has to be cos x. Let us say cos A, or you can say cos theta. Sin x cos theta minus, it is a cos x. So this has to be opposite, that is sin x, sin theta. Now let us make a triangle and theta, and this much part is cos theta. Cos theta nothing but adjacent side upon hypotenuse. Cos theta nothing but adjacent upon hypotenuse. So what is c? C is the adjacent and hypotenuse c square plus d square. And this part is the sin theta. Sin theta nothing but opposite upon hypotenuse. That means d is equal to opposite side. Therefore d. Now, so y equals to sin inverse of cos theta into sin x minus sin theta into cos x. Now, writing properly, sin inverse, properly means order. It is already in order. To make you understood properly, I am writing in order. So we have the cos x into sin theta. Now compare with which formula? Sin of a minus b. Sin of a minus b equals to sin a cos b minus cos a sin b. So this expression is fitting into the sin of a minus b. Therefore, sin inverse of sin of a minus b, where a equals to x and b equals to theta. So after that this is equal to sine inverse. This is equals to sine inverse, and sine will get cancelled. We get x minus theta, because we know the formula. Sine inverse of sine theta equals to, this is the formula, sine inverse of sine p equals to p. This is the formula. And what is theta? Theta can be obtained from this diagram. Tan theta equals to d upon c, implies theta equals to tan inverse of d upon c. This is the value of theta. Now come back here. We have y equals to x minus theta value, nothing but tan inverse of d upon c. Now we will be doing differentiation, and so differentiating with respect to x. So dy by dx equals to differentiation of x minus tan inverse of d upon c with respect to x. So derivative of x is 1 and tan inverse d upon c is a constant. Derivative of that equals to 0. Therefore, what is the final answer? dy by dx equals to 1. This is the final answer. Now previous two problems were very lengthy. Now we want to reduce the length in this question. So first, it is also similar nature. Here we got 3, 4, 5. So we have to test the first. Before starting, test it. How to test it? Here is a 3 and here is a 4, and 3 square plus 4 square. You do the square of these two numbers and take out the root. You must get 5. If you are getting 5, you are on right track. Otherwise, we require another procedure. So here is a 3 and 4. 3 square plus 4 square equals to 9 plus 16 equals to root 25 equals to 5 we got here. So that means here we can make the one side. Here is a 3. 3 is the one of the side, and 4 is the another side of the right angle triangle, and 3 square plus 4 square under root of that equals to 5 is the hypotenuse. Now we are rewriting the given question, that is a cos inverse. We are writing 3 upon 5 cos x minus 4 upon 5 sin x. And here is a cos inverse. That means inside the bracket also we need to get the cos inverse only. So cos of a plus b. There are one formula of cos of a plus b equals to cos a cos b minus sin a sin b. So we need to apply this formula here. We have to reduce the bracket term so that we fit that much part in terms of cos of a plus b. So here is so what we do here, 3 upon 5. 3 upon 5 should be the cos theta. So here is the cos theta equals to 3 upon 5. So writing the theta here, we need to decide which side is opposite and another side is the adjacent. So we need to decide opposite and adjacent side here. So depending upon the requirement, 3 upon 5 has to be cos theta. Therefore we place the theta so that 3 becomes the adjacent side, and sin theta, that becomes the 4 upon 5. So y equals to cos inverse. In place of 3 upon 5 writing cos theta cos x, and in place of 4 upon 5 writing sin theta and sin x. So y equals to cos inverse of theta minus x, theta plus x. So that is equals to theta plus x. From this one, what is the theta? Theta is nothing but tan inverse of 4 upon 3. So y equals to tan inverse of 4 upon 3 plus x. Tan inverse of 4 upon 3 is a constant. Derivative of constant is 0. Therefore dy by dx equals to derivative of tan inverse 4 upon 3 is 0 and derivative of x equals to 1. So what is the final answer? dy by dx equals to 1. Now example number 17, y equals to cos inverse of 1 minus x square upon 1 plus x square, find dy by dx. Sometimes what happen, whenever you are doing derivative of inverse trigonometry functions, by putting in place of x equals to, for example, x equals to tan theta, x equals to cos theta, or something in place of x, so that it converts into some suitable trigonometric form, and the given the complicated problem gets simplified into very suitable algebraic form. So for example, here is the 1 minus x square upon 1 plus x square. We know that one formula, 1 minus tan square theta upon 1 plus tan square theta, that is equals to cos 2 theta. This is the formula. That means here in place of x, if I put tan theta, then the problem will get simplified to very suitable form. Therefore what I am doing, I am telling you put x equals to tan theta. As soon as I put the x equal to tan theta, implies theta equals to tan inverse x. Let us remember it. We will be utilizing back after the at the final stage. We will be utilizing theta equals to tan inverse of x. So I am having y equals to cos inverse, and in place of x, what I am doing, I am writing here the tan theta. Therefore it is a 1 minus tan square theta upon 1 plus tan square theta. So this is equivalent to cos inverse of cos 2 theta, that is equivalent to 2 theta. Therefore y equals to 2 theta. What is theta? Theta nothing but tan inverse x. Therefore y equals to 2 tan inverse x. Now differentiating with respect to x. So dy by dx equals to differentiation of 2 tan inverse of x with respect to x. The 2 is a constant, so that will be taken outside. So dy by dx, 2 is the being constant, 2 into derivative of tan inverse x. So that is equals to 2 into 1 upon 1 plus x square. Therefore, what is the final answer? The final answer nothing but dy by dx equals to 2 upon 1 plus x square. Example 18, y equals to sin inverse of 3x minus 4x cube. Find dy by dx. Here we know the formula, sin 3 theta equals to 3 sin theta minus 4 sin cube theta. That means in the given problem, we are putting x equals to sin theta. As soon as you put x equals to sin theta, implies theta equals to sin inverse x. Therefore, the given problem becomes y equals to sin inverse 3 sin theta minus 4 sin cube theta. So this is equivalent to sin inverse of sin 3 theta. So that is equals to 3 theta. So y equals to 3 theta. But what is theta value? Theta value nothing but sin inverse of x. So putting here sin inverse of x. Now differentiating with respect to x. So we have the dy by dx equals to differentiation of 3 sin inverse x with respect to x. So dy by dx equals to 3 is taken outside, and differentiation of sin inverse x nothing but 1 upon under root of 1 minus x square. Therefore dy by dx equals to 3 upon under root of 1 minus x square. So by substitution, by putting x equals to sin theta, the problem becomes very simple. If you directly do that 3x minus 4x cube, by taking directly, it becomes at least 2 pages, and it becomes very lengthy as well as. So whenever that problem based upon trigonometry given, think about, does it suitable to some formula like sin 3 theta, sin 2 theta, tan 3 theta, etc. Then you put accordingly. Now I will help you. I will solve one more problem in which tan 3 theta is involved. So the next problem I am going to do in which the tan 3 theta is involved. So let us see how the simple problem is. The next problem is, Next example, example number 19. Find dy by dx if y equals to tan inverse of 3x minus x cube upon 1 minus 3x square. Before starting this problem, I want to recollect that tan 3 theta equals to 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. That means I am going to put x equals to tan theta. Therefore, y equals to tan inverse of 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So y equals to tan inverse of tan 3 theta, that is equals to 3 theta. Now what was the x? X equals to tan theta, implies theta equals to tan inverse x. We are going to put back this value. Therefore y equals to 3 tan inverse of x. Till now we have not done any derivative. We just simplified by putting x equal to tan theta. Now we are going to do derivative, that is the dy by dx equals to differentiation of 3 tan inverse of x with respect to x, that is equals to 3 into derivative of tan inverse x, nothing but 1 upon 1 plus x square. Therefore dy by dx equals to 3 upon 1 plus x square. This is required solution. Example number 20. If y equals to tan inverse of 5ax upon a square minus 6x square, find dy by dx. We have the 5 tan inverse. Whenever the tan inverse is given in such a condition, you have to see that the addition will give the numerator and multiplication will give the denominator. So for example, here is a 5ax upon, here is a square taken common, then 1 minus 6x square upon a square. A simplification is required. Y equals to tan inverse 5 x upon a divided by 1 minus 6 into x upon a whole square. Now you have to select the two terms such that addition will give the numerator and multiplication give the denominator, such as 5xa can be written as 3x upon a plus 2x upon a, that is equals to 5x upon a, and then multiplication, that is 3x upon a into 2x upon a equals to 6x square upon a square. If this condition is valid, then you write here tan inverse of, here is write it as what you write 5, that is a 3x upon a and plus 2x upon a divided by 1 minus 3x upon a multiplied by 2x upon a. Now let 3x upon a equals to tan a, implies a equals to tan inverse of 3x upon a. Let 2x upon a equals to tan b, implies b equals to tan inverse of 2x upon a. Therefore y equals to tan inverse of tan a plus tan b upon 1 minus tan a into tan b, which is nothing but equivalent to tan of a plus b. This is equivalent to a plus b. but therefore y equals to a plus b, but a equals to tan inverse of 3x upon a, and b nothing but tan inverse of 2x upon a. We just now simplified. We are not at all done any derivative part. Now we shall be doing derivative part now. So differentiating both sides with respect to x. So dy by dx equals to differentiation of tan inverse 3x upon a plus tan inverse of 2x upon a with respect to x. This is equals to 1 upon 1 plus 3x upon a whole square into differentiation of 3x upon a plus 1 upon 1 plus 2x upon a whole square into differentiation of 2x upon a with respect to x. This is equivalent to 1 upon 1 plus 9x square upon a square into 3 upon a plus 1 upon 1 plus 4x square upon a square into 2 upon a. This is equivalent to a square upon a square plus 9x square into 3 upon a plus a square upon a square plus 4x square into 2 upon a. A get cancelled. Here also a get cancelled. So that is equals to 3a upon a square plus 9x square plus 2a upon a square plus 4x square. This is nothing but required dy by dx. Dear students, whatever I have done in last 1 hour, this is a drop in the ocean. There are the many more problems are left which I could have done here, but there is a time constraint. Because of the time and the length of the video, I have to stop here, and I request you that you go through your textbook and solve many more problems. If you do not get the solutions, or if you don't get the idea how to solve the problems, then please do contact me on my email address provided in the description box. Once you contact me in my description box, I shall be giving you my mobile number as well, as so that we can touch with one another. So in the next video, I am going to solve the derivative of implicit functions. So don't forget to watch the next video. Till then, wish you good luck, all the best. Before saying goodbye to you, I request you that to like, share and subscribe the video, so that subscribe the channel, so that I will reach to more and more needy people who are really the mad of mathematics. They want to do some future in their mathematics, so they will be benefited by watching my videos. So meet you again with another video. Till then, wish you good luck, all the best.